Great, so let's go ahead and play around with OpenCV a little bit. Specifically, what you'll learn in this lecture is you'll learn how to load images in Python using OpenCV, and you'll learn how to display them, resize, and then save the resized images in new image files. So load, display, resize, and write images. And I've got a nice image here of a galaxy. So I'll play around with this. The first thing you want to do is import the library. And then the second thing is you want to load the image in Python. So image would be equal to cv2.imageRead method. So the method expects now the path to the image that you want to load in Python. And that would be galaxy.jpg. So my script, the 1.py file, is in the same directory with galaxy.jpg. So I just need to pass the file name here. And then there is yet another parameter for image read, for imread method. And then this parameter takes 3 arguments. Now this parameter specifies how you want to read the image in Python. So do you want to read it as an RBG image, which means do you want 3 bands in your image? So you want a color image with a red band, a blue and green band. So if you want to read the image as it is, so with colors, you'd want to pass 1 here. If you want to read the image as black and white image, so in a grayscale, you'd want to pass 0. And having a grayscale image implies that your image will have 1 band. And I'll get back to bands and explain them in just a moment. So, and we also have -1, and this means a color image. But you also have an alpha channel, which means your image will have transparency capabilities. So if you apply operations that require transparency, you can do that when you load the image with a -1 argument here. Okay, so I'd like to try out 0. Great. Now, before I show the image, before I display the image on the screen, I'd like you to understand what this image object is about. So I'd want to print the type of it. Just like that. Execute the script. Script 1. Yeah, of course. And try again. So this is a NumPy n-dimensional array. And if you want, you can print that out. And you'll see the actual NumPy array. So this is a 2-dimensional array with values in the horizontal axis and in the vertical axis as well. So think of the image now, and this would be the very first, so the top left intensity value of the first pixel. So 14, for example, would be the intensity value in the grayscale for the first pixel of the image, so for the top left pixel of the image. And then for the second pixel and so on, and then you have these dots, which means Python cannot display the long list in here because you have a couple of thousands values in the first row, and then you have the second row of pixels in the image, and the third and so on, and this makes the matrix of the pixels of the image. And if you want to know how many numbers, how many values you have in the horizontal direction and how many values you have in the vertical directions, you can go ahead and print image shape. Okay, so let's say that the image resolution is 1485 by 990. So Python stores the image as a NumPy array, as a matrix of numbers, as easy as that. If you want to check the dimensionals of your array, of your image, you can do that with this expression. And you see that you have 2 dimensions. Now, if this was a color image, so with 3 bands, red, blue and green, things will change a little bit. So you've got 3 dimensions, and you also see that the new array is a bit different. So here you've got values for each of the bands, so for green, for red to green and blue. So I'd like to stick with the gray image, and what I can do now is I can display the image on the screen. And for that you want to use the image, so ImShow method, and this will display a window, and you want to name that window, so you want to put a title for that window, let's say Galaxy. And what you pass here is the image object, so this one. Great. And then what you want to do is you want to specify a time for your window to be closed, because this will show the window, but you also want to define some functionalities so that the user can close the window. If you put 0 here, when the user presses any button, the window will close. Let me change this to CV2. So if you put 0, the user can close the window pressing any button. If you want to put a time, you could say 2000, and that implies 2000 milliseconds. So that means 2 seconds. So we said how the user wants to close the window, and then you want to specify what to do when the user presses a button or waits for 2 seconds. So you want to destroy all windows. That's a method that closes the window. Good. Let's see what will happen. Okay, so we got the image displayed, and it waited for 2 seconds, and then it closed. If you put it at 0, the image will stay there, and if you press a button, it will close. Let me show the image again. Now, the reason that you don't see the image fit on my screen is that the image, as you see here in these values, is 1485 pixels high, so the height, this is the height, and it's 990 pixels wide. So my screen resolution is set at 1280 by 720. So that means that this image with this size doesn't fit on my screen, because my screen is too small for this. So in this case, let me close this. What you can do is you want to resize the image and then show the resized image. So we load the image, and before showing it, before passing it to the ImShow method, you want to say, let's say, resize image. That would be equal to cv2.resize, and this would get 2 parameters. So the first is, of course, is the image object that you want to resize. So img is our variable, and then you want to specify a tuple with the new dimensions. I would say 1000 by 500, and then you want to pass the new image here. So what's happening here is that Python is actually resizing the NumPy array. So it will take the array with this number of pixel, number of values, and it will create an array with this new dimensions. So what will happen there is that Python will interpolate those values. So it has quite a lot of values here, but then it goes from this to this. So when it sees, let's say it has 4 for one value, and then 6 for the neighbor value, and what Python will do is that it will get 4 and 6 basically, and it will just make a value out of it. So let's say 5. That's basically the idea. So it interpolates the values, and then it shows the interpolated image on the screen, which looks pretty nice in our eyes. Okay, let's see this. And this is the image, and you see that this is quite stretched a little bit. So it was a tall image, but now it's quite wide, and because this is actually the width of the image, and this is the height. So if you want, you can say 500 and 1000. Save again, And now you see more or less the true ratio of the image. But if you want to keep the ratio of the image, you'd want to go more advanced here. So let's say from this, so let's say we would want to show a size that is half of this, so that would keep the ratio of the image. So what we can do is we need access to these values, and we can grab those values from the shape method. So this produces a tuple with these two values, and then we go here and say image shape, and this would be this value, so 990, which has an index of 1. And then we have again image.shape with index of 0 for this number. And then we want to divide this by 2. Okay, and I expect to get an error from this, but let's see. So yeah, we've got an error. It says type error, integer argument expected got float. But here what we're doing here is that when we divide this number by 2, we will get a float. So we would get something like 742.5. In that case, what we want to do is convert this to an integer. So 742.5 would become 742. Okay, and let's keep the consistency, so integers for this as well. And let's see. We've got an invalid syntax here, so it points us to line 11 somewhere in the beginning, which can be quite misleading. So you want to see before that line, which is here, and you can see that this bracket here closes here, so we need another bracket which closes in the first bracket here. So save that, try again, and this time the image looks good. So you learn how to load an image in Python, and you learn how to resize an image, how to show an image on the screen. And now let's go ahead and write the resized image in a new file. For that you'd want to use the imWrite method, so image write. And you want to give a name to the new image, galaxy, let's say, resized.jpg. And then you pass the image object that you want to store in this file. So the comma goes outside here, and the image you want to store is resized image. That's it. Execute, and we got the old image resized on the fly. So Python gets the numpy array, it interpolates it, so it resizes it, and then it shows it on the screen. So this is galaxy, this one here, and then we can close this, and here we've got our new image, so galaxy resized. So if you go to the folder where these files are, you'll see that this image has new dimensions, so 495 by 742. And that's what I wanted to teach you in this lecture. Hope you enjoyed it, and talk to you later.